All right, today we're going to continue multiplying polynomials, but we're going to learn how to do it in a couple ways. And we're going to look more at binomials by binomials instead of monomials. So we're going to talk about multiplying a binomial by a binomial. So this is going to be 2 pieces times 2 pieces. So I'm going to show you one way, which we call double distribution, which you'll see me use a lot. And then I'm going to show you another method, which is called the box method. So our first example we'll do with double distribution. So let's do example 1. And it's going to be x plus 7 times x minus 3. So remember, with distribution, if I were to have a problem that looked like this, 5 parentheses x minus 3, you would tell me to distribute the 5 to the x, which would be 5 times 1. So I'd get 5x, and then I would do 5 times negative 3 and get negative 15. So now we're doing the same thing, but now we have 2 pieces in our first part. Like here was just a 5. Now we have 2 pieces. So what we're going to do is we're going to take our time and we're going to distribute each piece twice. So if there is no number, I would suggest putting a 1. And just like we did yesterday, add an exponent of 1 if there isn't one there. So the first thing I'm going to distribute is 1x to the 1x. So 1 times 1 is still 1 because you multiply the coefficients. X to the first times x to the first is x to the second. Then I'm going to distribute the 1x to the negative 3. So 1x, 1 times negative 3 is negative 3. And then there's x to the first, and there's no x, so remember it's just x. So I now did the 1x times both things in the second parentheses, and now I'm going to do the 7 times both. So I'm going to do 7 times 1, which is a positive 7. And there's an x here, but no x here, so I get another x. And then 7 times negative 3, which is negative 21. So if you do it correctly, you'll get 4 terms. So when you multiply 2 things by 2 things, right, you get 4 terms. So now if I look for my like terms, in the middle, I have negative 3x's plus 7x's. So that's going to give me a positive 4x when I combine those. So I'll bring down my negative 21, and I'll bring down my 1x squared. And there's my final answer. Let's do another one using this method before I show you the next method. So let's do example 2. This time we're going to do 3x minus 6 times 7x minus 2. So remember, the first thing we do is we add our exponents if there isn't any. So this is a 1 and this is a 1. So we're going to do 3x times 7x. So the first things times the first things. So 3 times 7 is 21. X to the first times x to the first is you add them, x to the second. Now 3x to the first times negative 2. So 3 times negative 2 is negative 6. There's an x to the first, but no x here, so I just keep it. And you can put it to the first if you want. Then I'm going to do the negative 6 because I did the 3x to both. So now I do negative 6 times 7, which is negative 42. There's no x here, but there's an x here, so I bring it down. And then negative 6 times negative 2, and that gives me positive 12. I have 4 things, so I know I multiplied everything. So now I have negative 6 and negative 42, and that's going to give me a negative 48x. And I'll bring down my plus 12, and I'll bring down my 21x squared. And there is my final answer. So that's how you do the double distribution method. You can do these two problems using the box method. And so I'm going to do the box method with the same problem, so that way you can see we get the same answer. So I'm going to copy down the same first problem. So we'll make this example 3, but it's going to be the same as example 1. So x plus 7 times x minus 3. So what you're going to do here is you make basically a grid. And we have a 2 by 2 grid. And I'm going to start with this one here. So I have a 1x, 1, and I have a positive 7. So I'm going to put those on that side. And then up here, I'm going to start with this one. So I have a 1x, 1, and a negative 3. So then all you do is, like a grid, you multiply these. So this box times this box gives me 1x squared. 1x1 times 7 gives me 7x. 1x1 times negative 3 gives me negative 3x. And negative 3 times 7 gives me a negative 21. So now if I take these, you'll notice my like terms now are along the diagonal. And 7x's plus 3x's is 4x's. My 1x squared is there, and my negative 21 is there, and 4x's was positive. And you'll see I get the same answer here, right, as I did up here. So this method is really more math and algebra, and this is a visual. So some of you might like this method. So we're going to do example 2, also using the box method, so you can see the similarity again. So example 4, and we'll use the same one, 3x minus 6 times 7x minus 2. So I'll make my grid. And I'll fill stuff in where it goes. So 3x here, negative 6 here. So you just have to make sure you write it along the same side, this whole piece. And then the second one is 7x and negative 2. So we have 7x times 3x goes here. So that's 21. x1, right, and x1. So I get x2. 7 times negative 6 is negative 42. And I need the x. 3 times negative 2 is negative 6, and I need the x again because this one has an x. And then where these ones meet is positive 12. So I'll notice again on my diagonal, they are like terms. So I have 21x squared, negative 42, and negative 6 gives me negative 48x. And then I have my plus 12, which is the same answer that I had on example 2. So you get to choose which method that you like, and we don't really mind, but whatever method you choose, you should stick with it, so that way you can perfect it. Okay, I'm going to do 2 more quick examples, and then that's going to be it. So let's do example number 5. Sometimes they're going to write a problem like this, 2x minus 5 squared. And this actually means to use the same methods that we just used. But this square, if you remember, that means the same expression or whatever it is twice. So what that really means is that I'm going to write 2x minus 5 times 2x minus 5. And now it looks exactly like we just did. So you can add your little ones for your exponents that are missing. And this one I'm going to use my distribution. So 2x1 times 2x1 gives me 4x to the second. 2x to the first times negative 5. So 2 times negative 5 is negative 10, and I need an x. I did the first one times both of them, so now I do this one. So negative 5 times 2x again gives me negative 10x again. And negative 5 times negative 5 gives me plus 25. I know I did it right because I did a binomial times a binomial. I got 4 terms. Then I just have to look. The inside should combine. So I will get 4x squared. Negative 10 minus 10, if you type in your calculator, is negative 20 plus 25. So that's just one that might look a little different, but you use the same method, and you can use the box method if you want. Now, the last thing I just want to show you is sometimes they're going to do a little bit of a bigger problem, and it's going to be a binomial. So let's do 3x minus 3 times a trinomial. So 2x squared plus 4x minus 2. So if you look at this right now and you think about the double distribution method or the box method, I have two things, right? 2 terms multiplying by 3 terms. So 2 times 3 is 6. So I should end up with 6 terms if I do my box or my distribution twice. So here we go. These are missing exponents, so we can add our 1s so we don't remember to add, right? Okay, so I have to do 3x1 times 2x to the second. 3 times 2 is 6. X to the first times x to the second is x to the third. 3x to the first times 4x is 12, so we have plus 12. X to the first times x to the first is x to the second. 3x to the first times negative 2. 3 times negative 2 is negative 6, and I have my x to the first. So I did 3x times 1, 2, 3 things, and I'm done. So now I have to do the negative 3 times each. So negative 3 times 2, negative 6, and I have to bring the x squared. Negative 3 times 4, negative 12, x, because there's nothing. Negative 3 times negative 2 is negative 6. Now my combining like terms looks a little different here because you'll notice I have a couple different ones. So I see an x to the second here and a negative 6x to the second here. So that's going to give me positive 6x to the second. Then I have a negative 6x to the first and a negative 12x to the first because nothing's there. So that's a negative 18x. And there's no other x to the thirds, so I just bring down 6x to the third. And there's no other numbers by itself, so I bring down negative 6. So this time, I don't end up with a trinomial like all the other ones. I end up with a polynomial. But I had 1, 2, 3, 4, 5, 6 terms, so I know I did it right. Now, you'll see these as you get a little bit more advanced, but we wanted to make sure we showed you for today.